All right, so today we're diving deep into software testing. Whether you're a developer yourself or just curious about how those apps and websites we use every day actually get made, understanding functional and non-functional testing is super important. It's really about making sure that the software not only works, but it works well.
Yeah, exactly. And it's kind of like thinking about a car. I mean, you could have a car that just gets you from point A to point B, sure, but you want a car that's got a smooth ride, that handles well, all the bells and whistles.
Okay, I like that analogy. So functional testing is making sure the car starts, drives, brakes, the basics, right? But where does non-functional testing fit in?
Well, with non-functional testing, we're looking at how that car performs. Is it fuel efficient? How comfortable is the ride? Does it handle well in corners? Those things are all really important, even if they're not directly related to just getting from A to B.
So it's not just working, it's working well. And I'm seeing here in the software world, we've got these different types of functional testing. We've got unit testing, integration testing.
Right, so you start with unit testing, where you're testing each individual component in isolation. Like, think of it as making sure each wheel on that car is properly inflated and balanced before you even put it on the car. And then you move on to integration testing, where you're testing how those components work together, like making sure the wheels are properly aligned with the axle and the brakes are working in sync.
Got it. So we're going from individual parts to seeing how they all work together. Then there's system testing. That's got to be like taking the whole car for a test drive, right?
Exactly. You're looking at the entire system as a whole. Does it start? Does it brake? Does it steer? It's all about making sure all those different parts work seamlessly to actually deliver what they're supposed to.
And then finally, we have acceptance testing. I imagine that's like handing the keys to the customer and seeing if they like it.
Perfect analogy. Acceptance testing is all about getting that user's seal of approval, making sure the software meets their needs, expectations, really the final checkpoint before you release it out into the world.
This is making a lot more sense now. Now, for these functional tests, we're talking Selenium, QTP, and Postman.
Exactly. These are the tools that really help us automate the testing process, find those issues early on. Selenium is especially popular for testing web applications. It actually simulates what a user would do, clicking buttons, filling out forms, all to make sure the web app is behaving correctly.
Okay, let's talk about the other side, non-functional testing. I see we've got a whole bunch of types. Performance testing, load testing, stress testing, security, usability. It feels like a whole other world.
It is a bit. It's all about those qualities that make the user experience good or bad, even if they're not directly related to, the core function of the software. Performance testing, for example, is like seeing how fast that car can go, how it handles at those high speeds, and how quickly it accelerates.
Okay, so load testing. Would that be like filling the car up with passengers and luggage and seeing how it performs, under a realistic load?
Precisely. We're trying to simulate real-world scenarios. You want to make sure it can handle the number of users you expect, without any hiccups or slowdowns.
And then stress testing. That's where we push the limits, right?
Exactly. We want to see how much the software can actually take before it breaks. You overload the system, simulate extreme conditions, really find out what its breaking point is.
So it's like seeing how much weight the car can hold before the suspension just gives up.
Exactly. We need to find those weak points and reinforce them before they cause problems in the real world.
And security testing.
Yep.
Well, obviously super important these days. It's like making sure the car has an alarm system and that the doors are locked, right?
Absolutely. Security is crucial. We use specific tools and techniques to look for any vulnerabilities, any weak spots that hackers could exploit. Protecting user data is the top priority.
And then there's usability testing. Is that about making sure the car is comfortable to drive and the dashboard isn't too confusing?
You got it. We want to make sure users can easily find what they need, complete tasks efficiently, and really have a good experience using the software. If it's a pain to use, they'll just find something else.
I'm already seeing how crucial both functional and non-functional testing are to making software that people will actually want to use. But just to make sure we're all on the same page, can we break down the key differences between these two approaches?
Sure. At its core, functional testing is about making sure the software does what it's supposed to do, based on the requirements and specifications it was built from. Non-functional testing, on the other hand, is about how well the software does those things.
So functional testing is making sure the engine starts, and non-functional is about how smoothly the engine runs, how fuel efficient it is, how much noise it makes.
A perfect analogy. And just like that car needs a functioning engine, ain't a smooth ride. Good software needs to excel in both of these areas.
Okay, I'm getting the picture. It seems like these two types of testing have slightly different objectives. So what are we really looking for with each one?
With functional testing, we're really looking for errors in the software's functionality. Does it do what it's supposed to do without any bugs or glitches? Is the output correct? Are there any missing features?
So it's like checking the blueprint, making sure the software follows the plan.
Exactly. Non-functional testing is more about evaluating those aspects that might not be outright errors, but can still impact the user. Things like, how fast does it load? How secure is it? Is it easy to use?
So are we looking for things like slow loading times, security holes, or a confusing interface?
Exactly. And the way we approach testing these two things is different too. Functional testing is often more black box. We're testing the software's functionality without really knowing how the code itself is written. But with non-functional testing, we often need a deeper understanding of how the software is built, its architecture and design, to really get at those performance and security aspects.
So functional testing is like taking the car for a drive without looking under the hood, and non-functional is popping the hood open and making sure everything's in order.
Exactly. And just like a mechanic needs different tools to work on different parts of the car, we use a bunch of different tools for functional and non-functional testing.
Speaking of tools, we mentioned Selenium for functional testing. Are there specific tools for the non-functional side of things?
Oh, absolutely. For performance and load testing, there are tools like JMeter and LoadRunner. They can simulate thousands or even millions of users interacting with the software at the same time.
Whoa, so it's like having a virtual stadium full of people all trying to use the software at once.
Yeah, pretty much. And that helps us see how the software performs under pressure. Does it slow down? Does it crash? We got to know its limits. And then for security testing, there's tools like OFB Zapin. It can actually scan the software's code, looking for vulnerabilities and potential security risks.
It's like a digital security guard, making sure no one can sneak in and steal any data.
Exactly. And these tools are all about making sure that, along with being functional, the software is robust, secure, and user-friendly. All of those things are crucial.
Yeah, it's all starting to come together now. I'm curious, when it comes to doing these different tests, is it a one then the other kind of thing? Or do they overlap throughout the development process?
It really depends on the project and the stage of development. It's not a one-size-fits-all approach, but typically functional testing starts pretty early in the cycle, as soon as you have individual modules or components that are ready to be tested.
So it's like testing each part of the car as it's being built, rather than waiting till the whole thing's finished.
Exactly. You want to catch those bugs early before they become bigger problems later on. Non-functional testing often comes a little bit later, once the main functionalities are in place and working.
So it's like fine-tuning the car's performance once we know the engine actually starts and the wheels turn.
That's a great way to put it. The point is, you want to make sure the software not only works, but works well under all sorts of conditions.
Okay, this is all really clicking now. Functional testing lays the foundation, making sure the software does what it's supposed to do, and then non-functional testing refines it, making sure it's a joy to use.
Absolutely. And building successful software is kind of like building a house. You need a strong foundation and having details to work to make it livable and enjoyable.
All right, so we've talked about the types of functional and non-functional testing, what we're looking for, the approaches, the tools, but what about the pros and cons of each? Are there situations where one type is more important than the other?
Another great question. Let's start with functional testing. One of the big pros is that it's relatively straightforward to plan and carry out. You have clear requirements, clear specs, so you can design tests to make sure the software ticks all those boxes.
So it's like having a checklist, making sure all the essential features are there and working correctly.
Exactly. But the downside is, functional testing doesn't tell you anything about how the software performs under pressure, how secure it is, or how easy it is to use. You could have software that passes all of the functional tests perfectly, but still crashes when too many people use it, or it's just really frustrating to navigate.
So it's like a car that looks great and has all the features, but breaks down as soon as you try to drive it fast.
Precisely. Non-functional testing has its pros and cons too, of course. The big advantage is that it helps us find and fix those issues that can really impact the user experience, even if they're not outright bugs.
So it's like taking the car for a test drive on different roads and different weather conditions to see how it handles in the real world.
Exactly. But the downside is that non-functional testing can be more complex and time-consuming. You often need specialized tools and expertise, and it can be tricky to simulate real-world usage perfectly.
So it's like you need a whole team of engineers and a fancy test track to really put the car through its paces.
Yeah, sometimes it feels that way. But the main point is that both functional and non-functional testing are crucial for building truly great software.
Okay, I'm really starting to see the big picture here. It's not about picking one type of testing over the other, it's about using both and finding the right balance for your project.
Absolutely. And that balance will depend on the software you're building, who you're building it for, and what you want it to achieve.
This has been so insightful. I'm really starting to understand the complexity and importance of software testing. But before we move on, can you tell me a bit about how these different types of testing fit into the overall software development process? Is it a linear thing or more concurrent?
Great question. The software development lifecycle is rarely a straight line. It's often iterative, with lots of feedback and adjustments along the way. And functional and non-functional testing can happen throughout this whole life cycle, from the initial planning stages right through to the final release.
So it's kind of like constantly checking the blueprint as you're building the car, testing individual components, then assembling it, taking it for a drive, and making tweaks along the way.
Exactly. It's an ongoing process of testing, analyzing, and improving, all with the goal of delivering high-quality software that truly meets the needs of the users.
This is making so much more sense now. So functional and non-functional testing are like two sides of the same crane, both absolutely essential.
You got it. And finding the right balance between them is what makes the difference between software that just works and software that's truly excellent. And that kind of leads us to when you might focus more on one type of testing over the other. It's like our car analogy. If you're building a race car, performance is everything, but if you're building a minivan for a family, safety and comfort are going to be way more important.
Right. The needs of the project really drive those testing priorities. Got any real-world examples that illustrate this?
Sure, think of something like air traffic control software. It absolutely has to be functional. We can't have planes falling out of the sky because of a software bug. But in that case, things like reliability and fault tolerance are just as important, maybe even more so. A system failure there could be catastrophic.
Wow, yeah, that's a great example. The stakes are so high in that scenario, so those non-functional aspects become critical. What about an example where functional testing would be the main focus?
Well, imagine you're developing a mobile banking app, adding new features like person-to-person payments, investment options, budgeting tools, all that. In the beginning, you'd really want to focus on making sure all those new features work perfectly. Users need to be able to transfer money securely, track their investments accurately, manage their budgets without any issues.
So it's like making sure all the gears in a complex machine are meshing together correctly before you start worrying about how fast the machine can run.
Exactly. And once you've got those core functionalities nailed down, then you can shift more focus to the non-functional testing, making sure the app performs well under pressure, stays secure, and is easy and intuitive for people to use.
It shows how that balance between functional and non-functional testing can shift throughout the development process. Now, you mentioned earlier that the tools used for these two types of testing are often different. Can you expand on that a bit?
Sure. With functional testing, we often use tools that let us automate tests and mimic what a real user would do. Selenium, for example, is great for automating web app testing. It can simulate clicks, form submissions, navigating between pages, all those things a user would actually do.
So it's like having a robot user meticulously following our instructions and checking if the web app responds the right way.
Exactly. And then for testing APIs, those interfaces that allow different software systems to talk to each other, we often use tools like Postman. Postman lets us send different types of requests to the API and check that we get the responses we're expecting.
It sounds like these tools are crucial for making functional testing more efficient and reliable. What about on the non-functional side? Any tools for things like performance or security testing?
Definitely. For performance testing, we use tools like JMeter and LoadRunner that can simulate thousands, even millions of users hitting the software at the same time.
Wow, so it's like creating a virtual stadium full of users all trying to use the software at once to see if it can handle the pressure.
Uh-huh. That's a great way to put it. And for security testing, there are tools like OWASP OP that scan the software for vulnerabilities, looking for any potential security loopholes.
It's like having a digital security guard on duty, making sure no one can break in and steal any data.
Precisely.
Yeah.
And all of these tools are all about making sure the software is not just functional, but also robust, secure, and user-friendly. They're all essential parts of the process.
Yeah, I'm seeing that now. With all this talk about automation, though, I'm wondering if human testers are still needed. Can't we just automate everything?
That's a good question. And while automation is super helpful, it can't replace human judgment and critical thinking entirely. Humans are just better at certain things, like understanding complex scenarios and coming up with creative ways to find those really tricky bugs that automated tests might miss.
So it's like having a detective working the case, someone who can follow their instincts and explore those uncharted areas to uncover clues that others might overlook.
Exactly. Plus, humans are much better at evaluating the overall user experience. They can give feedback on how intuitive the software is, how aesthetically pleasing it is, whether it really meets the needs of the target audience.
It's not just about making sure the code works, it's about making sure the software is actually something people will want to use.
Absolutely. That human element is especially important in areas like usability testing, where subjective feedback and real-world user insights are key.
Makes sense. So even with all the automation advancements, human testers are still a vital part of the process. Now, I'm curious about how these different types of testing affect the software development process as a whole. Do they help us build better software?
I'd say both functional and non-functional testing are absolutely crucial for delivering high-quality software. Functional testing makes sure it does what it's supposed to, plain and simple. It catches those bugs early on before they turn into bigger headaches down the line.
So it's like quality control at every stage of the manufacturing process, making sure each part works before it's assembled into the final product.
Exactly, and non-functional testing takes it a step further by focusing on those aspects that can make or break the user experience, performance, security, usability, all of that. By addressing these non-functional aspects, you can create software that's not only functional, but also enjoyable and satisfying to use.
Yeah, because no one wants to use software that's slow, buggy, or frustrating. In today's competitive market, having a great user experience can make all the difference.
Absolutely. And on top of meeting user expectations, both types of testing can also make the development process more efficient and less expensive. Catching those bugs early on saves you from having to go back and fix them later, which can be costly and time-consuming.
It's like preventative maintenance, taking care of those small issues before they turn into big problems.
Exactly. And it's not just about preventing problems, it's also about finding ways to improve. Non-functional testing can show you how the software performs under different conditions, which can help you optimize performance, scalability, reliability, all that.
So it's a constant feedback loop with testing informing development and ultimately leading to a better, more robust product.
Precisely. Now, earlier we talked about Selenium for testing web applications. What are some other tools commonly used in functional testing?
Yeah, I'm curious about that. What else is out there?
Oh, there are tons of tools. Besides Selenium, another popular one is QTP, which stands for Quick Test Professional. It's a really powerful tool for automating functional tests, especially for those big enterprise applications. It's known for being user-friendly and for being able to handle complex testing scenarios.
So for organizations with those really big, complicated software systems, QTP might be the go-to choice.
It's definitely up there. And then you have tools like Appium, which are designed specifically for testing mobile apps. With mobile devices being so ubiquitous these days, Appium is crucial for making sure those apps work smoothly across different platforms and screen sizes.
So it's like a universal translator for mobile apps, making sure they run correctly on iOS, Android, and whatever new platforms pop up.
Exactly. And then there's API testing tools like Postman, which we talked about earlier. APIs are like the glue that holds all these modern software systems together, letting them communicate and share data. And Postman makes sure all those systems are speaking the same language and understanding each other.
Perfect analogy. It seems like there's a whole ecosystem of tools out there for functional testing.
There really is, and it's constantly evolving. New tools and techniques are popping up all the time. It's a really exciting field to be a part of.
It definitely sounds like it. I'm learning so much about the intricate world of software testing and how crucial it is for building successful software. But with all this emphasis on testing, how do we know when we've tested enough? Is there a point where we can say, okay, we're good to go?
That's the million-dollar question. And honestly, there's no easy answer. Software testing isn't about reaching some perfect state of 100% bug-free code that's usually impossible. It's more about finding a balance between risk and cost. You have to consider how critical the software is, what the consequences of a failure would be, and how many resources you have available for testing.
So it's like trying to find the sweet spot between building a car that's indestructible and one that's affordable and practical for everyday use.
Exactly. It's a balancing act, and there's no one-size-fits-all approach. That's why it's so important to have experienced testers who can assess the risks, prioritize testing efforts, and make those tough calls about when enough is enough.
It makes sense. You need that human judgment to navigate those complex decisions. Now, what about automation in non-functional testing? We've talked about tools like JMeter and Load Runner for simulating those high user loads, but are there other areas of non-functional testing where automation can help?
Absolutely. Automation is becoming increasingly important in all sorts of non-functional testing. For instance, security testing tools can now automatically scan code for vulnerabilities, find potential security risks, and even suggest ways to fix them.
So it's like having a virtual security consultant constantly keeping an eye on the code and looking for any weak points that could be exploited.
Exactly. And for usability testing, there are tools that track user interactions, analyze where people click and what paths they take through the software, and flag areas where users might be getting stuck or confused.
It's like having a virtual focus group, giving you insights into how real people are using the software and pointing out areas that could be improved.
Precisely. And automation can go beyond just simulating user loads in performance testing. There are tools that automatically monitor performance metrics like response times, resource usage, and error rates, giving you a detailed picture of how the software behaves under different conditions.
It sounds like automation is really changing the game for non-functional testing, giving testers powerful new tools to do their jobs even better.
It really is. Automation isn't about replacing human testers. It's about giving them the tools they need to be more efficient and effective. It lets them focus on those complex tasks that require human judgment, like exploratory testing, usability testing, and analyzing the results of all those tests to find patterns and trends.
It's a true partnership between human expertise and technological innovation, working together to create the best possible software.
Exactly. And that collaboration is becoming increasingly important as the world of software development gets more complex and fast-paced. It's all about making sure those software products continue to meet the needs of users in a world that relies more and more on technology every day.
This deep dive into functional and non-functional testing has been so insightful. We've covered so much: the different types, the tools, the impact on the overall software development process. But before we wrap up, I'm curious, are there any emerging trends in software testing that have you particularly excited?
Oh, there are always exciting new developments in software testing. One trend that's really gaining traction is the use of artificial intelligence, AI, in testing. AI-powered tools can analyze massive amounts of data, spot patterns and anomalies, and even generate test cases automatically, which makes the whole testing process much more efficient and effective.
It's like having a virtual testing assistant that's constantly learning and improving, helping us catch those tricky issues that we might have missed on our own.
Exactly. AI can also be used to tailor those test cases to specific user profiles and usage patterns. This helps ensure that the software is really meeting the needs of diverse users, ultimately making it better for everyone.
Wow, that's incredible. It seems like AI has the potential to totally revolutionize the way we approach software testing, making it smarter, more efficient, and more personalized.
I think so too. It's a really exciting area to watch. Another important trend is the shift-left approach to testing. This means integrating testing earlier in the development cycle, even before any code is written.
So it's like catching errors in the blueprint stage before any bricks are laid or walls are built, preventing those costly rework scenarios we talked about earlier.
Precisely. The shift-left approach requires close collaboration between developers, testers, and everyone involved in the project, ensuring that quality is built into the software from the very beginning.
It sounds like a much more proactive and collaborative approach to software development, where quality and user satisfaction are prioritized from day one.
Exactly. And these are just a couple of the exciting trends shaping the future of software testing. It's a dynamic field that's constantly evolving, driven by the need to create software that's not only functional, but also secure, reliable, and user-friendly in our increasingly digital world. It really feels like testing is becoming less of a separate step and more integrated into the whole development process.
Yeah, building quality in from the start.
Exactly. And it's an ongoing thing, right? It's not like you test it once and you're done.
Yeah.
Software is always changing, new features get added, the environment it runs in changes, all that. So testing has to keep up to make sure everything still works the way it should and the quality stays high.
Like a car, you got to take it in for those regular tune-ups to keep it running smoothly. You wouldn't just buy a car and never get it serviced, right?
Right. Software needs those checkups too. It helps catch those little bugs or issues that can creep in when you update code or add new features.
Before we wrap up this deep dive, I want to go back to something we touched on earlier, the human side of testing. Even with all the automation, it seems like human testers are still really important. Why is that?
Well, no matter how advanced those automated testing tools get, they can't fully replicate human judgment and critical thinking. Humans are just better at grasping those really complex scenarios, thinking outside the box to find those sneaky bugs that automated tests might miss.
So it's like having a detective on the case, someone who can follow those hunches and dig into those areas that the automated tests might not even know to look at.
Exactly. And humans are also much better at evaluating the overall user experience. They can tell you if the software is actually easy and enjoyable to use, if it feels intuitive, if it really meets the needs of the people who are going to be using it.
So it's not just about making sure the code functions correctly, but also about looking at it from a human perspective, making sure it's something people will actually want to use.
Exactly. That human element is especially important for usability testing, where you really need that subjective feedback and those real-world user insights.
It's a really interesting mix of technical skills and human intuition. So as we wrap up our deep dive into functional versus non-functional testing, what are the key takeaways you'd want our listeners to remember?
I think the biggest takeaway is that both functional and non-functional testing are absolutely essential for building high-quality software that people will love to use. Functional testing makes sure it does what it's supposed to, and non-functional testing makes sure it does it well.
Like two sides of the same coin, both equally important.
Exactly. And another key point is that testing isn't a one-time thing. It's an ongoing process that should be baked into every stage of the development lifecycle. That continuous testing culture helps ensure that software stays robust, reliable, and user-friendly as it grows and changes.
It's a journey, not a destination. And testing is the map that helps guide you toward creating truly exceptional software.
I like that, a journey and a map. And lastly, I'd emphasize that even with all the amazing progress in automation, human testers are still critical. Their intuition, their creativity, their ability to think outside the box, those are all invaluable for finding those subtle bugs and usability issues that automated tests just might not catch.
It's a powerful partnership, human ingenuity and technological innovation, working together to build software that truly stands out.
I agree. A powerful partnership indeed. And I think with that, we've pretty much covered the landscape of functional and non-functional testing.
Yeah, this deep dive has been incredibly insightful for everyone listening out there. We hope you've gained a better understanding of these crucial testing practices and how they contribute to building software that not only works, but works well. Thanks for joining us, and we'll catch you next time.